This is a tutorial on recognizing linear functions. Now, a function is just a special type of relation where every domain value has only one range value. And a linear function is just a special type of function that always graphs as a straight line. So let's look at our three examples here. Let's figure out if they're functions, and then we'll figure out if they're linear functions. So our first example here does appear to be a function. Every x value that we select has only one possible y value. So it is a function. However, this is not a linear function because of this little bend here in the v. First this function goes down and then it goes back up. So it is a function, but it's not linear. Let's look at the next one. Again, it appears to be a function because every x value we select only has one possible y value. And it is linear because it's in a straight line. So this is a linear function. Let's look at our last example. This appears to not be a function because for every x value, I can find multiple y values. So this is not a function. And if it's not a function, it can't be a linear function. So this is not a function. Now there are other ways to recognize linear functions other than just looking for straight lines on graphs. Say we're given a bunch of ordered pairs. Let's see if we can figure out if these ordered pairs are showing a linear function. Let's look at our first set, and I'm going to rewrite them a little bit different. Our x and y coordinates. Our x is 2, 3, 4, and 5. And our y coordinates are 37, 45, 53, and 61. So let's look at our x coordinates first. This is an increase by 1. And then again an increase by 1. And then again an increase by 1. And then on the y side, this is an increase by 8. And this is an increase by 8. And then this is an increase by 8. Because x's are increasing by the same amount every time, and our y's increase by the same amount every time, these ordered pairs represent a linear function. So let's look at the next example. Here again we have 1, 2, 3, and 4, and then 5, 8, 10, and 14. Again, our x's increase by 1 every time. And our y values increase by 3, then by 2, and then by 4. So because our x's increase by the same amount every time, but our y's do not, this is not a linear function. So let's look at our last set of ordered pairs. We have a 7, a 10, a 13, and a 16, and then an 8, a 6, a 4, and a 2. Now our x values increase by 3, again by 3, and again the last time by 3. And our y values decrease by 2, again by 2, and again by 2. So because the x's are increasing at the same value, 3, again and again, and our y values also decrease at the same value, this is a linear function. Now say you're not given any ordered pairs or any graphs, you're just given an equation, and we want to find out if this equation represents a linear function. If an equation does represent a linear function, we call it a linear equation. Now if an equation is linear, it can be reorganized into what we call the standard form of a linear equation, which is just this equation right here. Now in this equation we have our typical x's and y's, and our a, b, and c are just constants. The other thing to recognize about this equation is that the exponents for x and y are 1. If this is a linear equation, the exponents for x and y must be equal to 1. This means that x and y cannot be multiplied together. They cannot appear in the denominator or in an exponent, or they can't be under any square roots or any other kind of radical signs. For these to be a linear equation, it must fit this equation exactly. So let's look at our first example. Again, we're going to try to move this y is equal to 3x plus 6 into our standard form, which is ax plus by is equal to c. Now if you notice in the standard form, the x and y terms are on the same side of the equal sign. So with our equation here, I'm going to subtract 3x from both sides. We end up with negative 3x plus y is equal to 6. Now this is in the standard form. Our a is negative 3, our b is 1, and our c is 6. So y is equal to 3x plus 6 is a linear equation because we were able to move it around and make it fit the standard form. Let's look at our next example. 1/2 y plus 23 halves is equal to x. Again, we want to try to fit it to our standard form, and in our standard form, x and y is in the same side of the equal sign. So I'm going to subtract x from both sides, and I'm going to end up with negative x plus 1/2 y plus 23 halves is equal to 0. Now in the standard form, our constant term, the term without any x's or y's in it, is on the right side of the equal sign. So I'm going to move this 23 halves over by subtracting it from both sides. And we're going to end up with negative x plus 1/2 y is equal to negative 23 halves. This is now in the standard form. Our a is negative 1, our b is 1/2, and our c is negative 23 halves. So our equation 1/2 y plus 23 halves is equal to x is a linear equation. Now let's do our last example. Again, in our standard form, our x's and y's are on the same side of the equal sign. So I'm going to subtract 1 over y from both sides, and I'm going to end up with 2x minus 1 over y is equal to 1/4. Now this is not a linear equation. It's almost in the standard form, but if you remember, the exponents for our x and y must be equal to 1, which means our y's and x's cannot be in the denominator, they cannot be under a radical, or they can't be squared or anything like that. Here, this y is in the denominator, and there's nothing I can do to move it into the numerator and keep this in the standard form. So this is not a linear equation. Well, now that we know how to find linear equations, let's figure out how we can graph them. Let's look at these two examples. First, we'll test and see if they are linear equations, and if they are, then we'll graph them. So let's look at our first one. Y is equal to 2x plus 5. Let's see if we can fit this equation into our standard form, which is ax plus by is equal to c. So again, our x's and y's in the standard form are on the same side of the equal sign. So for y is equal to 2x plus 5, I'm going to subtract 2x from both sides, and I'm going to end up with negative 2x plus y is equal to 5. This is in the standard form, so this equation is indeed linear. Now to graph a linear equation, you simply pick x points and solve for y. To solve a linear equation, because it's a straight line, you always need 2 points. But really when you're doing these problems, always select 3, and I'll show you why. To graph this one, I'm going to choose negative 3, negative 2, and negative 1 as our x coordinates, and then we'll solve for y. So to plug in negative 3 first, we end up with y is equal to 2 times negative 3 plus 5. So we end up with y is equal to negative 1. So our first point is going to be negative 3 and negative 1. Let's do negative 2 next. So y is equal to 2 times negative 2 plus 5. So here y is equal to 1. So our next point will be negative 2 and 1. And then lastly, we'll plug in negative 1 for x. Y is equal to 2 times negative 1 plus 5. So our y is equal to 3. And our last point will be negative 1 and 3. So let's put these ordered pairs into our graph. Negative 3, negative 1. Well, negative 3 on the x-axis is here, and negative 1 is there. So we end up with a point right there. Next is negative 2 and 1, which would be right about there. And then negative 1 and 3 is right there. Now that we have our 3 points, we just connect the dots. And that's how you graph our linear function. Now the reason why we pick 3 points is to check our math. If this point had ended up out here, then either this is actually not a linear equation and we had messed up when we were testing it, or we had made a mistake when we were calculating our ordered pairs. That's why you always use 3 points, because if you make a mistake, your 3 points won't line up in a line. Now let's do our next example. X is equal to 5. Now to test if this is a linear equation, you usually want to put it in the standard form, but you may or may not realize that this equation is already in the standard form. In this case, ax plus by is equal to c. Our c is 5. Our b is 0, which is why there are no y terms in this equation. And our a is equal to 1. So x is equal to 5 is already in the standard form, so it is a linear equation. Now to graph it, you have to realize that x is always equal to 5. So it doesn't matter what the y value is. In trying to find ordered pairs, you could pick any ordered pair you want. But x is always equal to 5. So the ordered pair, 5, 1 would work, 5, 0 would work, 5 and 3 would work. Doesn't matter what the y coordinate is, as long as x is always equal to 5. So 5, 1 would be here, 5, 3 would be up there, and 5, 0 would be on the x-axis. And this is just a vertical line that passes through x is equal to 5. So that's how you graph linear equations. Now let's put all these ideas together in a word problem. Shasta has a new piggy bank. Every day she puts 30 cents in the piggy bank. The amount of money in Shasta's piggy bank is represented by the function f of x, where x is the amount of days she puts money in the bank. Give the domain and range of this function and determine if it's a linear function, and then graph it. Well, here's our function, f of x is equal to 0.30x. Now let's think about the domain and range of this function. Can Shasta put money in the bank a negative amount of days? Can she put money in the bank before she gets the piggy bank? Well, the answer is obviously no. So our domain is equal to x must be greater than or equal to 0, because negative numbers just don't work. Same thing with the range. Shasta cannot have a negative amount of money in her bank. Once the bank is empty, you can't take any more out. So again, our y's must also be greater than or equal to 0. Now, is this function a linear function? Well, remember, f of x is equal to y, and therefore y is equal to 0.30x. Well, if y is equal to 0.30x, and we want to know if this is a linear equation, we need to put it in the standard form. So to do that, we need to put x and y on the same side of the equal sign. So I'm going to subtract 0.30x from both sides. And we end up with negative 0.30x plus y is equal to 0. So it does fit into the standard form, and this is a linear equation. And now that we know it's linear, let's graph it. Well, let's pick points out of our domain that are easy to graph, and we'll plug them in for x and solve for y. So let's pick day 1, 2, and 3. If we plug in 1 for x, we get y is equal to 0.30 times 1. So y is equal to 0.30. So our first point that we're going to graph is 1 and 30 cents. Let's try 2. Y is equal to 0.30 times 2. So then y is equal to 0.60. So our next point will be day 2 and 60 cents. And then our third point, we plug in 3 for the day or for x. We get 0.30 times 3. So y is equal to 0.90. So the last point we're going to graph is 3 and 0.90. So now let's graph these 3 points. Here's day 1, here's 0.30, so our first point is there. Here's day 2 and 0.60, so our next point is there. And then day 3 and 0.90, so our last point is right there. Again, we connect the dots, and that's our linear function. And this concludes the tutorial on recognizing linear functions.